you're thinking about buying a house, but you really want to figure out how much area does a house cover? What is the square footage of the house, or what is the area of the foundation of the house? So right here we have the floor plan of the house, and you're tasked with finding its area. And you're given the dimensions of a bunch of walls of the house. This wall right here is 18 feet, this is 8 feet, this is 20 feet, 20 feet, 5 feet, 26 feet, 15 feet, and 25 feet, but you're a little confused. You know how to find the area of rectangles, but how do you find an area of a strange shape like this? So I encourage you to pause this video and try to figure out the area of this strange house footprint shape, floor plan shape, using the techniques that you already know about. So what you already do know about is how to find the area of rectangles. So if we can break this house's floor plan into a series of rectangles and find out the areas of those rectangles, then we can figure out the area of this entire house. So let's break it into a bunch of simpler rectangles. So I could have one rectangle here. It has a width of 20 feet and it has a length of 20 feet. So that would be a rectangle right over there. And we should be able to figure out its area. Then I could set up another rectangle that has a width of 26 feet and has a length, that's its length right over there. And we could think about in a second what that length actually is. Actually, let's think about that. How would we figure out what this length actually is? Well, this length plus 5 feet is going to be the same thing as this length over here. It's the same as the opposite wall of this rectangle. So this length plus 5 feet is 20 feet. Well, this must be 15 feet. So this blue rectangle is 15 feet long and 26 feet wide. Now let's add another rectangle. We could have one that's 18 feet long and then goes the entire length of the house. Goes the entire length of the house like that. And you might say, wait, how do we figure out its width? How do we figure out the width of this rectangle? Well, we know that this is 8 feet. We know that this is 20 feet. And we know that this is 26 feet. So the entire width is going to be 26 feet plus 20 feet. So 26 plus 20 gets us to 46 plus 8 gets us to 54 feet. So this is 54 feet right over here. Did I do that right? Let's see. 8 plus 36 would be 34 plus 20 is 54 feet. And then finally, we have one last rectangle to deal with. This rectangle right over here, which is 15 feet long and 25 feet wide. And so now we can calculate the areas of the different rectangles. So the total area is going to be the 20 feet by the 20 feet. So let's just multiply them. So it's going to be 20 times 20. That's this area right over here. Plus 15 times 26. So plus 15 times 26. That's this area right over there. Plus 18 times 54. Plus 18 times 54, which is this area right over there. And then finally, plus 15 times 25, plus 15 times 25, which is this area right over here. So we just have to now evaluate these things. So what is 20 times 20? Well, this is going to be 400. What's 15 times 26? Well, let's multiply it out. 26 times 15. 6 times 5 is 30. 2 times 5 is 10, plus 3 is 13. Now I'm going to multiply a 10 times 26, gets us to 260. And you add these two together, you get 390. So it's 400 plus 390. Now we've got to multiply 18 times 54, or 54 times 18. So let's do that. 54 times 18. 8 times 4 is 32. 8 times 5 is 40, plus 3 is 43. Now we're multiplying this 10 times 54, gets us to 540. And we add 2 plus 0 is 2. This 30 plus the 40 gets us to a 70, or it's a 3 plus a 4 in the tens place. And then 400 plus 500 is 900. So we get to 972. And one more of these multiplications, 25 times 15. And actually, we could do that in our head. This is 26 times 15. So 25 times 15 is going to be this minus 15. So it's going to be 300. You see, if you subtract 10, you get to 380. Subtract another 5, 375. Let me do it in that same color. So plus 375. And now let's add up these numbers. So we have 375 plus 972 plus 390 plus 400 plus 400. And so this gets us to 5, and this is a home stretch. We deserve a drum roll now. 5 plus 2 is 7. 7 plus 7 is 14, plus 9 is 23. 2 plus 3 is 5, plus 9 is 14, 17, 21. So the square footage of this house, 2,137 square feet.
Let us study some of the important facts and important points regarding the area, perimeter and diagonal of a square. This is the basic square in which 4 of the sides are equal. This side is equal to this side, is equal to this side, is equal to this side. A square needs no introduction. The area of a square is defined as A is equal to the square of the side, that is A square. This formula also needs no introduction. Now, the perimeter of a square is defined as the sum of the boundary wall of the square. Like if somebody starts his journey from here, he will travel this A, this A, this A and back to this point. The distance he travels is called the perimeter, and we can write that P is equal to, how many sides are there? 1, 2, 3, 4 sides, and each side has a length of A. So the perimeter will be 4A. These are the very basic formulas for the area and perimeter of a square. Similarly, there is a diagonal of the square. The line joining the opposite corners of a square is called the diagonal. So in this case, this is the diagonal and the length of this diagonal can be labeled as D. We know from Pythagoras theorem that D square will be equal to A square plus A square because this is a right angled triangle. So we can write that the square of the diagonal is equal to 2A square. Square of this side A square, square of this side A square. Therefore, D square can be written as equal to 2A square. We can now establish a few useful relationships. For example, we'll write relation between D and A, the diagonal and the area. We know that D square is equal to 2A square. We can write, since D square is equal to 2A square, we can obtain D square is equal to 2 into A. Because A square is known to be equal to the area, therefore the relation between D and A is D square is equal to 2A. So, this is the relation between the diagonal and area of a square. We can similarly establish a relation between the area and perimeter of a square. Relation between area and perimeter. Since these are the derived relations, I'll mark them as 1 and 2. We know that A is equal to square root of a, because a is equal to a square. By taking the square root of both the sides, we can write a is equal to square root of a. So we write, since a is equal to square root of a, therefore we can write p is equal to 4a is equal to 4 times the square root of area. So we can either use this, or to bring it into a more user-friendly form, we can write squaring. We get p square is equal to 16a. This is the relationship between the perimeter and area of a square. A is known to be square root of a, p is known to be 4 times a, equal to, we substituted a equal to square root of a, and then we squared both the sides of this equation. P turned into p square, 4a turned into 16a. I have always laid stress on derivations of formulas so that you can understand the concepts even more. Let us move to our next property. The next property is regarding the area, perimeter and diagonal of a rectangle. This is a rectangular field of length L and breadth B and diagonal D. We know that this is a right angle triangle. This is also, and this is also right angle. This is 90, this is 90, this is 90, and all the angles of a rectangle are 90 degrees. And this is the diagonal of the rectangle that joins the two opposite corners of the rectangle. The area of a rectangle is defined as the product of length and breadth. And perimeter, as usual, is the distance that one would have to cover if one has to go along the periphery of the rectangle. So it will be, this breadth will be travelled twice, here and here on the opposite side. This length will also be travelled twice. Therefore, we can write that perimeter will be 2 into length plus breadth. This is length plus breadth, and again the same length plus breadth is occurring 2 times. So perimeter is equal to 2 times the length and breadth of the field. And by applying the Pythagoras theorem to this right-angled triangle, we can establish a relation between the length of the diagonal and the length and breadth of the rectangular field. By Pythagoras theorem, we can see that the sum of the square of the hypotenuse, that is diagonal, should be equal to the sum of the squares of the length and breadth. These are the bare minimum things that you have to remember always. We can establish a relation between the diagonal D, the area A, and the perimeter of a rectangle. The relation can be established like this. Since P by 2 is equal to L plus B, we can take 2 to the lower side of P. P by 2 will become L plus B. Now we can square both the sides. Squaring, we get P square by 4 is equal to, this becomes P square by 4 is equal to L plus B whole square. We can open this by x plus y whole square formula. We will get L square plus B square plus 2 AB like 2LB in this case, which we can now write as L square plus B square. This joint thing can be substituted for D square. We'll write it D square, and this joint thing is known to be equal to the area A. So we can write it as plus 2A. Now we can take 4 to the other side. So we can write, which implies P square is equal to 4 goes as 4D square, and 4 into 2 becomes 8A. This is the relationship between PD and A of a rectangle. So, this is the relation that we have finally established between PD and A for a rectangle. Let us now check our next property. Pathway outside a rectangular field. Suppose this is a rectangular field of length L and breadth B. Let the width of this rectangular pathway around the field, let the width be W. The width is uniform on all the sides. It is W, and we have to find out the area of this pathway that has been added outside the rectangle. We have to find out the area of the shaded portion. To find out the area of the shaded portion, what we will do is, we will find out the area of the entire outer rectangle and subtract the area of the inner rectangle. Whatever will be left with would be the area of the shaded portion. Now what is the length of this length? The length of the outer rectangle, you can see that if this is length L, then it has been increased by W on this side and W on this side. Therefore, this length becomes L plus 2W. And similarly, the breadth of the outer rectangle, we can easily see that this breadth would be B plus, it is increased by W here and W here, so it will be B plus 2W. So we can write outer area will be the outer area, that is, I would write outer rectangle area would be L plus 2W into the breadth, which is 2W. This we can now simplify. LB plus 2BW, and this term will be 2LW. So we can write 2W into L plus B plus, this will be 2W into 2W, 4W square. From the outer area, we will subtract the inner area, which is L into B. So we will write subtract inner area LB. So when we subtract it, this term will go away. So what we will be left with is required area is equal to, this will be the term that will be left. We can take out 2W common. So it will be 2W, this L plus B plus this will be 2W. So this will be the required area. If you can remember this formula, then you can remember this formula. Sometimes it is required also. If you do not want to remember, then you can just see the method in which I have derived this formula, so that you can always derive it just in time. Let us move to our next property now. Pathway inside a rectangular field. In this case, the length of the outer field is L and the breadth of the outer field is B, and this is a pathway that has a width of W. It has been constructed on the interior of the rectangular field L and B. What we have to do is, we have to find out the area of this pathway. That is, we have to find out this area of the shaded portion. I will complete this so that we are able to visualize what is required. Now what is the length of the inner square, inner rectangle, the breadth of the inner rectangle? This breadth, you can see that from the outer breadth B, we have subtracted this W and we have subtracted this W. So from B, 2 W's have been subtracted. We can say that this breadth would be B minus 2W. And similarly, the length of the inner rectangle would be the entire length L minus this width and this width. So L minus 2W is the length of the inner field. We can write it L minus 2W. To find out the area of the hatched or shaded portion, we will obtain the area of the outer field, then subtract the area of the inner field. We will be left with the area of the shaded portion. So we can write outer rectangle area is equal to L into B. We can mark it as item 1. And the inner rect would be equal to, length of that is L minus 2W into the breadth of that is B minus 2W. We can now open these brackets, and what we will get is this LB and this minus 2WB and minus 2WL will give me minus 2W into L plus B, and this will be minus 2W into minus 2W. It will be plus 4W square. This we can mark as item 2. Now the required area is from 1 we will subtract 2 is 1 minus 2. So when we will subtract, this LB will be cancelled by that. This minus will turn into plus. And this plus will turn into minus. So what you would get is, take out 2w common, it will be L plus B minus 2w, which is the required relationship or the required value. There is another method of obtaining the same result. You could have treated this as one rectangle of length L and width W. This would have been another rectangle of length L and width W, and this smaller rectangle would be of width W and length B minus 2W. And add all these four areas, you would have obtained the same result. It is just how you do it. Let us move to our next property now. Two pathways inside a rectangular field. This is the situation. Let the length of the rectangular field be L and B be the breadth of the rectangular field, and there is a pair of pathways inside the rectangular field. The width of these have been taken as W. We have to find out the area for this shaded portion. The pathway is now inside the rectangular path, and it is a sort of a crossing two pathways inside a rectangular field. Let us see how we will do it. Let us write the required area is equal to, first of all, calculate the area of this strip. The length of the strip is L from here to here, and the height is W, or the breadth is W. So first of all, we have LW. To this, let us add the area for this strip, the width of which is W and the length of which is equal to this B. But as we have done, this square has got included twice, once with this pathway and secondly for this pathway. Let us remove this once. And what is the area of this? W into W. Remove W square. So I will write here, remove double area of inner square W by W. Now we can just collect omega W out. So required area will be W into L plus B minus W. L plus B minus W. So this is the required formula for the area of the pathways inside a rectangular field of length L and breadth B. Let us take up our next property now. I will first explain the problem. Suppose this is a rectangular field of length L and of breadth B. Now he says, what is the area of the entire figure if the length increases by a%. Now the entire increase has been given, not the width of this rectangular park or the paveway. The entire length increases by a%. So the new length is this one, this length becomes AL plus AL by 100. And let us suppose the breadth has also increased by k%. This means the new breadth becomes B plus KB by 100. I will write B increases by k%, and here I will write L increases by A%. We have to determine percent change in area. That is, we have to find out what this value is. Now we can write new area. New area will be new length into new breadth. We can write it as L into 1 plus A by 100. I have taken L common, and this will be multiplied by B into 1 plus K by 100. Here also I have taken B common, so it becomes B into 1 plus K by 100. I can now open it out. It becomes LB. LB I have taken on one side into 1 plus A by 100, 1 plus K by 100. This becomes 1 plus A by 100 plus K by 100 plus AK by So what is the increase in area? I'll write increase is equal to subtract LB. The original area was LB. From this, you will get the increase. I will write here the step: subtract earlier area LB to obtain the increase. So what will be the increase when you subtract LB from this? This LB is now being multiplied to all the four terms. The first one will vanish out. LB into 1 is LB, and when you subtract that LB, this LB, that is this 1 will go away, these 3 will stay. So we can write the increase is LB into A by 100 plus K by 100 plus AK by. This is what we have. And percent increase will be obtained by multiplying this by 100. The entire will be multiplied by 100. So I am writing it here into 100. So this 100 I can this 100 will cancel out this 100. This 100 will cancel out this 100, and out of 4 zeros 2 will be cancelled out. So my percent increase will be, if it is confusing, I'll just remove it and write the whole thing here. original area was LB, new area is LB into this by LB. This will be the percentage increase. We can now make cancellations. This LB will be cancelled by this, and this 100 and these two zeros will be cancelled by this 100. So what I will be left with is A plus K plus AK by 100. So this will be the required answer. The percent change is the sum of the two percentages and the product divided by 100. This is easy to remember, and many times questions come on this relationship. You can remember this relationship for your exams. But if you cannot remember, then you can follow these steps of derivation to obtain your answer just in time. Let us move to our next property now. Area of four walls of a room. Let me draw a diagram. Suppose this is a room and the length of this room is this. The breadth of this room is given here, and this is the height of the room. We can mark it as L, mark this as the breadth, and mark this as the height. What we have to do is, we have to find out the area of the four walls, that is, this wall, and this wall, and the back wall. We just have to exclude the area of the floor and the roof. So I will mark here no roof and no floor. The required area would be equal to, we can just calculate it. This is B and this is H. So this is one rectangle. The area of this wall will be BH. Since there is an equal area opposite this, so we will write it as BH plus BH. This is for this wall and the opposite wall. Similarly, come to the back wall. This L and this H, they form a rectangle, and opposite to the back wall and the front wall, you have the same area, the LH for back wall and LH for the front wall. So we will write it as plus LH plus LH. We can collect the like terms, 2BH and 2LH, which is equal to, take 2H out, 2H into L plus B, which is the required relationship. We'll close it right now. In our next tutorial, we'll take up the examination questions for rectangles and squares.